Happy Friday, guys. If you're watching this video, then you're kind of stuck on how to do the practice. So I want to remind you that this lesson is all about scatter plots, a graph that shows a relationship between two data sets on the coordinate plane. Those data sets are called bivariate data. That's data with two different, That's data with two different variables that are numerical observations. So we're looking at two sets of number parts. And we can call them X and Y, or we can call them whatever letters are in the um, problem. But in all of this, what we want to do is we want to look to see if there's a trend so that we can find the line of best fit, which is a line that we draw on the scatter plot that's kind of close to most of the data points. And remember, when we're doing that, we don't pay attention to outliers. Outliers are those points that lie a far distance away from the other values. And when you have an outlier, it's not part of the representative sample. Now, remember, as you're looking at the graphs and the pictures that are on your worksheet, you're looking to see, does it show clustering that shows a positive correlation, which is just like a positive slope? Does it show a negative correlation, which is like a negative slope? Or are the points, I don't know why I keep moving that around everywhere. Well, whatever. Or is there no correlation, meaning that there's no clear clustering, so that if I laid a pencil or anything down, I wouldn't see any kind of trend. So I'm going back over what I showed you in class yesterday. Remember, we talked about bivariate data, how you can compare height to shoe size. And as long as you have number data, how height is in inches, so you can see the data from 10 to 80, and the shoe size in inches, or the shoe sizes from a 0 to a 16, can show whether, or they can show a scatter plot, and we can look to see if there's a relationship between the points. In this one, each data point represents one person's height and shoe size. For example, if you can find 48,4, this little point, I did it again. I don't know how I'm doing that. This little point right there that I just circled, 48,4 represents someone who is 48 inches tall and has a shoe size of 4. And so this data plot that you're looking at shows data for 16 people. And so it shows 16 people's heights in inches and the size shoe that they wear. What we want to do is we want to look at that and see if there's any type of trend. We might see an outlier and we might see clustering. So let's talk about those so that you know the difference. An outlier is a data point that lies far away from the other points. So it's that person that has an unusually large shoe size. My children have unusually large shoe sizes. My son is 6'9" and had a size 15 shoe. Well, that would actually fall within our range and not be an outlier. But my son, who is 6'5", wears a size 14 shoe. And so even though he is very, very tall, his shoe size is very, very big for his height. So he would be considered an outlier. And outliers are not normally counted when you look at the data set for the line of best fit. But remember, they're the point that's far away from the others. You did this in 7th grade. Remember, when you looked at your box plots or the box and whisker plots, you had to find the interquartile range above the 3rd quartile and below the 1st quartile by taking those numbers and multiplying by 1.5, and it gave you the outlier. On a scatter plot, you can just look at the point to see. If it's far away from the others, it's an outlier and it does not count. A cluster is when we look at points that are closely packed together and they're used to determine an overall trend. You can see the cluster that's marked for you here, and that's a very strong cluster. They're very, very closely packed together. But these points right here that I just circled are also a cluster. It's just not as strong as the one above it. So how do you tell whether there's a trend or not? Well, if you see a cluster, you can kind of imagine that if you put your pencil or a line through it, that it kind of goes all in the same direction. And in this one, they do. So we would say it has a relationship or an association. So the relationship between the data sets is called an association or a correlation. And we talk about it being a strong one if it clusters together tightly, and we call it weak if it's spread out more and you can still see the trend, but you can't see them closely packed together. And so we use it to see if there is a relationship between two sets of data. Now, ask yourself, when you looked at the picture, did you see a relationship between a person's height and shoe size? I see one, and they talk about it right here. There's a positive association if the value of the y variable increases as the value of the x variable increases. So since both of these are increasing, you can see that they had a positive line and there's a linear association. It tends toward a straight line. Now remember, we said it can show a positive, a negative, or no association. In the case of height and shoe size, we saw a positive association. We would see a negative association if the y value is, look at me doing that again, if the y value is decreasing while the x value is increasing. So as one value increases, the other one decreases. So the age of a car and the value shows a negative association. As a car's age increases, its value tends to decrease. But this is not a linear association because the line is curved. Remember, linear means line, it has to be straight. So it's modeled by a curved line, and so if you had to call it anything, you call it nonlinear association. We're going to focus on linear associations this year, and you'll be looking at nonlinear associations in the higher math courses you take in high school. Now, variables have no association if the increase in the x variable has no apparent relationship with the y variable. And you've practiced this with me as well. If you look at the age and number of siblings, notice that the age in years, as it increases, the number of siblings doesn't seem to have any relationship because there's no clustering. The points are just scattered everywhere. So you would say there's no association or there's no trend, and you would say that you would say there's no relationship between the age in years and the number of siblings. So this is just a recap. When you look at a scatter plot, you should be able to describe the association you see between the variables. Is there an association? Is it positive, negative, or none? You should also be able to tell me whether it's strong or weak. You should be able to notice if you see any outliers, and you should be able to circle them and mark them. And you should also be able to tell me whether you can see a trend that would give you a line. Is it linear? So always pay attention to those three things. Goodness gracious. Look at the form, the direction, and the strength. And then again, this is just a recap of positive correlation. That means that they're moving in the same direction. As one variable increases, the other variable increases. Or it could happen when one variable decreases and the other variable decreases. An example that they gave us in this lesson is the length of an iron bar will increase as the temperature increases because it stretches that iron out. A negative correlation is a correlation in the opposite direction, and that means that as one variable increases, the other variable decreases. And they give it a science example. The volume of gas will decrease as the pressure increases, or the demand of a particular commodity is increased as price of a commodity is decreased. Law of supply and demand from history or civics. A correlation or zero correlation is if there's no relationship between the two variables. So as one variable's value changes, the other variable remains constant. So we call it a zero or no correlation. Now these videos are videos that you can watch if you need additional information. And then you can always use your notes that we did as guided practice in class to help you see positive and negative correlations. I need you to take out your sheet for practicing with scatter plots, and I need you to complete it. If you don't have the sheet, don't worry, you can go online and get it. It's in the same lesson that this video link is found in. I hope this helps you, but if you still need help, feel free to reach out to me because you know if you email me, I'll be able to answer you right back. Good luck and remember, do your very best.